Good morning, students. In today's class I am going to explain about polynomials. First of all, I am going to give introduction for the polynomials. Constants, variables, constants and variables. Already you know constants. Constant means what? All the numbers. All the numbers we call it as constants. Name means 1, 2, 3, 4, so on. All this, any number we call it as constant. Means why you are calling it as constant? Because suppose I will take a number 2. Means its value is fixed. 2 means what? 2 only. Its value does not change. Its value is fixed. That's why all these we are calling it as constants and variables. Variable means what? Suppose I am taking x. Here I am taking one alphabet. I am assuming that alphabet is x. Here I can take x equals to 0. I can take x equals to 1. I can assume, or I can take x equals to 10. I can take x equals to minus 3. I can take x equals to minus 10. Any number or any value I can take. Its value is changing. Whenever I am taking, means whatever the value we can assume, we can take. Whatever the value we can assign, we can give for this x. We can consider or not, we can assume. So that's why like this we call it as variables and constants. Variables means what? Its value is not fixed. Like those we call it as variables. Constants. Constant means what? Its value is fixed. Now we understood the difference between constants and variables. Constants means what? Its value is fixed and its value does not change. Variables means what? Its value is not fixed. Its value will change. Whatever the value we can assign, we can assume, we can take. That one we call it as variables we call. Now, already you know fundamental operations. Fundamental operations means what? Addition, subtraction, multiplication and division. These 4 operations we call it as fundamental operations we call that. They are addition, subtraction, multiplication and division. These 4 operations we call it as fundamental operations, are also called as arithmetic operations also we call. Both are same one. Now, if I will take one variable and one constant, and if I will apply this fundamental operation, suppose I am taking one variable x and I am taking one constant phi. Suppose I am taking one variable and I am taking one constant. For this both variable and constant, I am going to apply this fundamental operation. Means what? First I am taking variable x and constant. For this I am applying the operation, that is addition. Next, afterwards I am taking variable x and applying subtraction, x minus 5, x into 5. Next, x by 5. Now I am getting new expression I am getting. So this only we call it as algebraic expressions we call. Means if you will take one variable and if you will take one constant, whatever the operation you will do, whatever you are getting this new one, this one we call it as algebraic expression we call. We call it as algebraic expression. Call it as algebraic expression we call. If you will take one variable and one constant, if you will do any fundamental operations, whatever you get, that one we call it as algebraic expression we call. In an algebraic expression, this one we call it as first term and this one we call it as second term we call. Here how many are there? Here 2 terms are there. This one we call it as algebraic expression. This one also, in this also 2 terms are there. In this only 1 term is there. Here also only 1 term is there. Now first term. Next you are going to learn about polynomial. When an algebraic expression we call it as a polynomial. Next you are going to learn that one. Next we are going to learn about polynomial. When an algebraic expression we call it as a polynomial. In an algebraic expression, variables power are non-negative integer. Once again I am saying, in an algebraic expression, variables powers are non-negative integers, variables powers are non-rational numbers, and in the denominator also variables should not be there. Like those algebraic expressions we call it as a polynomials we call it. Now here I am observing, here in this the variable is x. Here x power is 2 and here x power is 1. For the variables power is non-negative numbers, means what? Here negative numbers are there. Whenever variables power is negative numbers, means what? Those expressions we will not call it as a polynomial. When you call it as a polynomial, means what? If the variables power is positive natural numbers, then only you call it as polynomials. Here I am going to give some examples to identify polynomials and not polynomials. Now, here I have taken some examples. If you observe properly in this, here why you are calling this as a polynomial? Because 3x, here x power is 1. Here x power is 1. 1 is a positive integer. So this one we call it as a polynomial. And you observe in this, here x power is rational. Whenever the x power is rational number, means what? Those we will not call it as a polynomial. Indirectly those we call it as, here 7x to the power of 3 by 2. Here we call this as not a polynomial we call. Here 7x minus 8. Here x power is 1, positive number. So you call this as a polynomial. And again if you observe properly, here 3x, x power is positive. But whenever you come to the second term, here 4x to the power of minus 3. 4x to the power of minus 3. Here x power is minus. Again we will call this as not a polynomial. This one is also not a polynomial. And again here x power is 2, positive only. Here x power is 1, 7x plus 8. And again here x is in the denominator. Again, so this one is also not a point. Just you remember, in an expression, if the variables powers are negative numbers, or variables powers are negative numbers, or x variables powers are fractional numbers, nothing but rational numbers, and whenever the variables are in the denominator part, variables are in the denominator, those expressions we will not call it as a polynomials. When you call it as a polynomial, means what? If the variables power is positive integers, if the variables powers are positive integers, then only we call it as a polynomials we call. Okay, now next you are going to learn about degree. Here I am taking one example, 3x square minus 13x. Here x power is positive and here also x power is positive. That's why you are calling this as a polynomial. In an algebraic expression, the variables powers are non-negative integers. Those expressions only you call it as a polynomials. Now next, degree of a polynomial. Degree means what? In an algebraic, in a polynomial, variables highest power only we call it as a degree. Here I am going to give one example for you. (3x square plus 7x plus 6). Here I am taking one. Now whenever you are going to find degree, first of all you have to check whether it is a polynomial or not. Here, okay, here x power is positive and again here x 7x to the power of 1, there x also 1 positive only. Whenever the x powers are positive means what, indirectly this is a polynomial. In this, here the 3x to the power of 2, so here x power is 2 and here x power is 1. Variables highest power only we call it as degree. Here the variable is x, in this the highest power is 2, so the degree of this algebraic expression is 2, the degree. Suppose I am taking another example, 3x plus 7x to the power of 8 plus 9x to the power of 15, like this I am taking one algebraic expression, polynomial. In this, here x power is 1, here x power is 8 and here x power is 15. There the highest power is 15, so the degree of that polynomial is 15. Degree means what? Variables highest power only we call it as the degree of the polynomial. Next, I am going to tell you about the general form of a polynomial. What is the general form? General form of a polynomial. General form of a polynomial. P of x. P of x. How we have to one polynomial in that the variable is x. P of x means what? Polynomial in that the variable is x. P of x equals to a naught x to the power of n plus a1 x to the power of n minus 1 plus a2 x to the power of n minus 2 plus so on up to plus an minus 1 to the power of x plus an. Now I am going in this where a0, a1, a2, an minus 1 so on up to an are coefficients, we call it as. Coefficients means what? Already you know. Numbers before the variables we call it as the coefficients. Now how we have to, this is a polynomial in variable x. How we have to read it as polynomial? This is general form of a polynomial in variable x. A naught x to the power of n plus a1 x to the power of n minus 1 plus a2 x to the power of n minus 2 plus so on up to plus an minus 1 to the an minus 1 x plus an. Now how to remember this? Once again I am going to write. So here what is there here? 0. So a naught x to the power of, here whatever it is that here I am writing a to the power of x a1 x to the power of, here always you have to start with 0, next after 0 next term, so whatever you will write here x to the power of n minus 0 you have to write plus a2 x to the power of n minus 2 plus so on up to, so on next to what you will get? You will get a n minus 1 x to the power of n minus n plus 1 it will, if whatever you write here it plus an. This is the general form of a polynomial. How you will remember? If you will write whatever you will write here a naught x to the power of n minus, here I am writing 0, so x to the power of you write n minus 0, here you are writing 1, so x to the power of n minus 2, a2 x to the power of n minus, so on up to ax n minus 1 means what? Here plus n minus n goes cancel, again it will remain x to the power plus an. So here an is a constant, where always in a polynomial the last term you will get a constant. Previously you written plus 6 constants. Already I said you constant means what? It does not contain the variable terms, those we call it as a constant. This is the general form of a polynomial. In 1 mark you will ask p of x equals to, always numbers are starting with 0, like that you can remember, a naught x to the power of n plus a1 x to the power of n minus 1 plus a2 x to the power of n minus 2 so on up to, directly you can write an means what? Constant, like that also you can write. Okay, this is general form of a polynomial. In this where a naught, a1, a2, a3 so on up to an, we call it as coefficients. Now next, 0 of a polynomial we call. 0 of a polynomial. 0 of a polynomial means what? A polynomial for which value its value will become 0. That one we call it as a 0 of a polynomial. Suppose I am taking a polynomial p of x, polynomial in variable x. I am taking one polynomial p of x equals to x square minus 2x minus 3. I am taking one polynomial. In this, suppose I will substitute. If I will substitute x equals to 1, suppose x equals to 1 means what? In x place you have to write 1. If x equals to 1, what is the meaning of this one? Means wherever x is there, in that place you have to write 1. Suppose I am taking a polynomial p of x equals to x square minus 2x minus 3. If x equals to 1 means what? In x place how much you have to write? You have to write 1. Means 1 square minus 2 into 1 minus 3. 1 square how much you will get? You will get 1 minus 2 into 1 2 minus 3. How much you will get now? 1 minus 2 minus 1 minus 1 minus 3. How much you will get now? Minus 4. So how much you have substituted? You have substituted x equals to 1. So you can write it as p of 1, which implies p of 1 equals how much you are getting now? You are getting minus 4. So for this polynomial, if I am substituting x equals to 1, how much I am getting? Its value is minus 4. The same thing if you will substitute x equals to minus 1. Suppose if I will substitute x equals to minus 1, then what you call, how much it will become? It will become x, which implies minus 1 whole square minus 2 into minus 1 minus 3. Minus 1 whole square, how much it will become? 1 minus into minus plus 2 minus 3. How much it will become now? 3 minus 3. 3 minus 3 equals to 0. If you will substitute x equals to minus 1 in this, its value is becoming 0. Wherever, anywhere, if you will substitute any value, its value will become 0. In this polynomial, if I will substitute x equals to 1, its value is becoming 0. So that's why any value if you will substitute, its value will become 0. That number here minus 1, for this polynomial you call it as 0 of the polynomial. Which number if you will substitute, its value will become 0. That number you call it as 0 of the polynomial. We call 0 of the polynomial means if you will substitute any value, after substituting its value will become 0. That number, whatever that number is there, we call it as 0 of the polynomial, we call it as. So in today's class, first of all I said you that constants means what? Constant means what? Those numbers, alphabet numerical numbers only call it as constant. Next, variables. Variables means what? This lowercase alphabets. What is the difference between constants and variables? Constant means what? Its value is fixed and its value does not change. Variables means what? Its value is not fixed. Whatever the value we can take, we can assign, it will consider. That one we call it as variables. Next, algebraic expression. Algebraic expression means what? The fundamental, whatever the operation if you will do on these constants and variables, that one we call it as algebraic expression. Next, polynomial. Polynomial means in an algebraic expression, the variable's powers is non-negative integer. Those expressions only call it as polynomials. And next, after polynomials, already I said you what are the conditions when you call it as a polynomial means what? If the variable's powers are fractional numbers means what? It is not a polynomial. The variable's power are negative numbers means what? It is not a polynomial. And whenever the variables are in the denominator means it is also not a polynomial. These three conditions especially you have to remember when you call it as a polynomial. First one, if the variable's powers negative, the variable's powers are fractional numbers, rational numbers, that one. Denominators are whenever in a polynomial or in an expression, if the variables are in the denominator means it is not a polynomial. These three you have to remember. After polynomials, next I was explaining about the general form of a polynomial. P of x equals to a naught x to the power of n plus a1 x to the power of n minus 1, so on up to an. That is the general form. After this, next 0 of the polynomial. 0 of the polynomial means for which value its value is becoming 0, that one we call it as 0 of the polynomial. So for this class, introduction is completed. Next we are going to do problems from 3.1, that is third chapter, first exercise. Okay, introduction part is completed. If you know this, whatever this degree also I was explaining. Degree means what? In an algebraic, in a polynomial variable's highest power only we call it as degree. This, if you know all this, degree, 0 of the polynomial, general form, then easily you can able to do the exercise 3.1 problems. In exercise 3.1, first one, in p of x equals to 5x to the power of 7 minus 6x to the power of 5 plus 7x minus 6. What is the coefficient of x to the power of 5? Zero of a polynomial means what? For which, if you will substitute any value, its value is becoming 0. That value we call it as 0 of the polynomial we call. Exercise 3.1, in this first bit, whatever he has given that given p of x equals to 5x to the power of 7 minus 6x to the power of 5 plus 7x minus 6. Now here he has given one. Now first of all we will check whether this is a polynomial or not. Let us check. Here 5x to the power of 7. Here x power is 7, positive only. Okay. Here x power positive. Here x power also positive. So this is a polynomial. Is polynomial. Now what is asking? Is asking to check the coefficient of x to the power of 5. Coefficient means what? Number before the variables. Here first of all, okay, coefficient 3x square. Variable before number is 3. So here coefficient is, see, this one we call it as the coefficient, this one we call it as the base, this one we call it, 2 we call it as the power or index we call. Suppose a x to the power of n is there. In this a we call it as the coefficient, x we call it as the base, n we call it as the power or index also we call it. This is, suppose if we will take 3x to the power of 7, in this 3 we call it as coefficient, x we call it as a base, 7 we call it as power or index or exponent also we call it. So x to the power of 5 before, what is there here? Minus 6. So the coefficient of x, what is first one is asking coefficient of x to the power of 5. What is the coefficient of x to the power of 5? First one, minus 6. Next, the second one. What is the degree of p of x? Already I said to you, degree means in an polynomial variable's highest power only you call it as degree. Let us will check what is the highest power. Here x power is 7. Here x power is 5. Here x power is 1. So which one is the highest power is 7. So the degree of that polynomial is 7. Next, constant term. Constant means what? Without the variables. This is not a constant, this is not a constant, this is not a constant. Here variables are there, not there. Whenever the variables does not contain, that one only call it as variable. So their constant term is minus 6. In this polynomial, constant term is minus 6. The degree of this polynomial is 7. And the coefficient of x to the power of 5 is minus 6. First one completed. Next, what is there here? Second bit. State which of the following statements are true and which are false. Give reasons for your choice. There, first one is the degree of the polynomial. First one. Second bit. First one. What is asking? The degree of the polynomial root 2x square minus 3x plus 1 is root 2 is given. Now we have to say whether it is true or false. Now first of all you observe here root 2x square minus 3x plus 1 here he has given. In this x power is 2 and here x power is 1. So what the degree? The degree is how much now actually? Degree of degree of p of x like that he has given. Okay. Degree of degree of root 2x square minus 3x plus 1 is 2. But actually there what is given there? He has given that root 2 he has given. Root is what for this? Root 2 is the coefficient of x square. Whatever he has given in that, root 2 is the coefficient of x square and its degree is 2. So it is true or false? It is false. That is wrong. Next, the coefficient of x square in the polynomial in the second one. What is the coefficient of next? The second one. What is that second one? 3x cube minus 4x square plus 5x plus 7. The coefficient of x square. The coefficient of x square. How much is there here? Minus 2. In this x square term, coefficient is minus 4. But there what he has given there? 2. The coefficient of x square in that polynomial is minus 4. There has given the 2. So it is false, wrong. That is, the degree of a constant term is 0. Whatever the constant term you will take. Suppose I am taking one constant number 6. This 6 I can write it as 6 into 1 I can take. 6 into 1 how much you will get? You will get 6 only. This one still I can write it as x to the power of 0. You remember that? Already you know in laws of exponents, any number to the power of 0, its value is 1. So x to the power of 0, it is value. Now you can write it as 6x to the power of 0. Now in this what is so the degree of a constant term is 0. It is true only. Next, 1 by x square minus 5x plus 6 is a constant, is a quadratic polynomial. 1 by x square minus 5x plus 6. Before going to this, first of all you should know about this degree. If degree is 1, then we call it as okay. If degree is 1 means what will not, there is no particular name is not there. If a polynomial, if degree is 2 in a polynomial, if degree is 1 means what? Simply we call it as suppose 3x to the power of 1 means what? How we will write? We will write as 3x. Okay. If degree is 1 means what? There is no particular name. But if degree in a polynomial, if its degree is 2 means what? Then how we will call it as a quadratic polynomial we call it as. If degree is 3 in a polynomial, if its degree is 3, then we call it as cubic polynomial we call. In a polynomial, if degree is 4 means what we call it as a biquadratic polynomial we call. Degrees, I was explaining about. In a polynomial, if degree is 1 means what? We will read directly, there is no particular name. In a polynomial, if degree is 2, in a polynomial, if degree is 2 means what we call it as a quadratic polynomial. If a polynomial, if degree is 3 means what we call it as a cubic polynomial. If a polynomial, if its degree is 4 means what we call it as a biquadratic polynomial we call. If degree is 5 means what? Then we have to read it as degree 5. There is no particular names from degree 5 onwards, up to 4 only. For second, third, 4 only. Okay. Degree 2 means what? Quadratic. 3 means cubic. 4 means biquadratic. Now actually our question is why I was explaining means what? Here he is asking fourth one. 1 by x square minus 5x plus 6 is a quadratic polynomial. So first of all you observe now where the variables are in the denominator part. Variables are in the denominator part. If the variables are in the denominator part means what? We call it as a polynomial first of all? No, we will not call it as a polynomial. Next, the degree of a polynomial is 1 more than the number of terms in it. Yes. Next, here he has given some of the problems. Third one. Third one he has given that given p of t equals to t cube minus 1. There he has given that p of t equals to t cube minus 1. Now he is asking to find the value of p of 1, p of minus 1. Here he has given one polynomial p of t. Here the variable, see, always you have to observe p means what? Polynomial. In brackets whatever is there, that one we call it as a variable you call. Now this is a polynomial in variable t, that the meaning. P of t means what? This is a polynomial in variable t. P of t equals to t cube minus 1. Is asking to find its value. P of 1 means what? In t place how much you have to substitute? 1 means 1 cube minus 1, which equals to 1 cube value is 1 minus 1, which equals to 0. If you substitute t equals to 1 in there, its value is becoming 0. So 1 what you call it as a 0 of the polynomial. Whenever I am substituting t equals 1, its value is becoming 0. So 1 we call it as a 0 of the polynomial for this. The same way if I will substitute x equals to minus 1 means what? T equals to minus 1 means what? Minus cube 1 minus 1. How much you will get now? Minus 1 cube minus 1 minus 1. How much you will get now? Minus 1 minus 2. Next. In the same way you do this. P of 2, P of minus 2, P of 3 and P of minus 3. These 4 you do yourself. Next. Fourth one. Check whether minus 2 and 2 are the zeros of the polynomial given polynomial. What is the given polynomial? Is x to the power of 4 minus 16. Here he has given one polynomial, that is x to the power of 4 minus 16. Now he is asking check whether minus 2 and 2 are the zeros of the polynomial or not. Okay, first of all I am assuming let in this the variable is x. Whatever is given in that polynomial, what the first of all you have to identify the variable. What is the variable is x. So I am assuming let p of x equals to x to the power of 4 minus 16. Here given that one, I am assuming it as x. Now how much is, check whether minus 2 and 2. So first how much I am taking now? X equals to, what is that first value is in the question? Minus 2. So you first of all you take x equals to minus 2, you substitute. In the x place how much you are substituting? Minus 2 means p of minus 2 equals to, you substitute in x place how much now? Minus 2 means what? Minus 2 whole to the power of 4 minus 16. Minus 2 whole to the power of 4, how much you will get now? 16. 16 minus 16, how much you are getting? Its value is 0. So which implies what you can write now? P of minus 2 equals to 0. Whenever in this polynomial x equals to minus 2, if you will substitute, its value is becoming 0. Once again, so one polynomial is there. In this polynomial you observe properly, brackets, whatever the brackets is there means that value you are substituting. In this polynomial if you will substitute x equals to minus 2, its value is becoming 0. So minus 2 we call it as the 0 of the polynomial you call. Minus 2. Here he has given one polynomial, that is x to the power of 4 minus 16. So p of x equals to x to the power of 4 minus 16. In this polynomial how much you are substituting? X equals to minus 2. Minus 2 if you will substitute, minus 2 to the power of 4, its value is 16. 16 minus 16, 0. If you will substitute x equals to minus 2, its value is becoming 0. So whenever you substitute, minus 2 means so, therefore what you can say, minus 2 is 0 of the polynomial x to the power of 4 minus 16. There he has given one more value also, that is, what is that one more value? One more value is 2. Now let x equals to, you take, let x equals to means how much will you get now? P of 2. P of 2 equals to 2 to the power of 4 minus 16. 2 to the power of 4 value is 16. 16 minus 16, 0. Means, which implies P of 2 means what? In this polynomial, if we substitute 2, means its value is becoming 0. Therefore, what you can say? 2 is also 0 of polynomial x to the power of 4 minus. Therefore, what you can write now? Therefore, minus 2 and 2r means if you will substitute minus 2 and minus 2 both times, you are getting its value is 0. Therefore, minus 2 and 2r are zeros of the polynomial x to the power of 4 minus 16. Now in the same way you do one problem. Check whether, fifth problem, in 3.1, fifth problem you do. Check whether 3 and minus 2 are the zeros of the polynomial p of x when p of x equals to x square minus x minus 6. Now yourself you try this fifth one. Easy only. Okay. Next. The next class we are going to learn about parabolas.